When trying to find the antiderivative of a rational function, one technique that is appropriate is to use integration by partial fractions. The first step in trying to solve an integration by partial fractions is decomposing the original fraction. In this case, we have two factors of the numerator, x minus 2 and x minus 5. And if we assume that we can decompose this particular rational function into those two factors, we end up with x minus 2 and x minus 5 as the two possible factors that will be related by a particular constant, which we'll call a and b. And somehow we're going to want to end up with these two fractions adding up to 1 over x minus 2 times x minus 5. So after you figure out what two factors you have, you'll want to combine the two into one single statement. In this case, we find the common denominator and find out that a times x minus 5 plus b times x minus 2 over x minus 2 times x minus 5 has to be equal to 1 over x minus 2 times x minus 5, which is the original. Once we do that, we know that the denominators of these two fractions are equal. In that case, we know that the only way that we're going to make the two fractions equal is if the numerators are equal. And to do that, we say that a times x minus 5 plus b times x minus 2 has to equal to 1. Now, there are many techniques that you can use to try to find out what a and b, those constants, need to be. But one technique is what's called the Heaviside method, in which case we're going to try to plug in for x the different factor values that we see with x minus 5 and x minus 2. In the first case, we're going to try x is equal to 2. When we try x is equal to 2, we notice that the first part of the expression then becomes negative 3a, and the second part of the expression disappears, the b times x minus 2, so that we're left with the statement that negative 3a is equal to 1, and a is equal to negative 1/3. Then we can do the same technique by trying to make the a term vanish by plugging in x is equal to 5. In this case, we end up with 3b is equal to 1 and b is equal to 1/3. So, in the next part of this, we can see that we can rewrite the statement as 1 over x minus 2 times x minus 5 is equal to negative 1/3, because that was what we determined a to be, over x minus 2, plus 1/3 over x minus 5. We can then rewrite the integral statement as negative 1/3 times dx, the integral of dx over x minus 2, plus 1/3 times the integral of dx over x minus 5. The whole object of doing integration by partial fractions is that generally we can reduce our fraction statements into integrals that we can evaluate using natural logs. In this case, we're going to integrate each part separately. The integral of 1 over x minus 2 dx will get us natural log of x minus 2 times the constant. And then we've got the integral of dx over x minus 5, which then produces natural log of x minus 5 times 1/3. With our conclusion being that we can factor out a 1/3, and since we are subtracting with the natural log of x minus 2, that goes to the bottom inside our natural log input. And don't forget your plus c.